Hi, in this session we will be discussing about differentials. Okay, so what are differentials? Before we discuss differential, let us look back at our chain rule. Okay, so suppose our function f is depending on two variables x comma y, and suppose these x and y are in turn dependent on some other variables called t. Okay, then we know how to write df by dt. What is df by dt? It is nothing but dou f by dou x into dx by dt plus dou f by dou y into dy by dt. So this we have studied this result in chain rule. Okay, so if you avoid this t, the term would qualify either notation like this: df is equal to, if I am avoiding this t, dou f by dou x into dx plus dou f by dou y into dy is called the total differential coefficient of f. Total differential coefficient, or in other words differential of f. Okay, total differential coefficient, it is called total because you are taking the derivative of all the variables on which f is dependent. Okay, so f is dependent on x and y, so you are taking derivative with respect to all those variables and you are multiplying with dx and also dy respectively. So this is called total differential coefficient, or simply the differential of f. Okay, so what is the use of this differential? This differential will help you to estimate the change in f when you know the change in x and also change in y. Or in other words, if you have a quantity, for example, if you have a rectangle, if you are measuring some rectangle and if you are measuring the length of the rectangle and the breadth of the rectangle, and suppose on measurement of that some errors have been crept in. Okay, sometimes you have not accurately measured the length, some error has come in the measurement of length of that rectangle, and also some error has come in the measurement of breadth of the rectangle. Now we have to analyze how this errors will affect the error in the computation of area. So basically the theory of differentials will help you to compute the area, compute the errors in the total quantity, the dependent variable, by on comparing it with the errors in the computation of the independent variables. Or in other words, you can compute the errors in f with respect to the errors in x and y, etc. Okay, so this is the application of differentials. Now we will do some problems in which we will try to compute the differentials. Okay, so basically this is an example of differentials. Okay, so we can extend differential to many terms. Suppose my f is dependent on three variables x, y, z. If I am asked to write the compute the differential, it is nothing but dou f by dou x into dx plus dou f by dou y into dy plus dou f by dou z into dz. So I hope you understand what is a differential. Now let us compute some differentials. Okay, so let us compute. So first I am writing z. So this is first question, z is equal to 7x minus 2y. So what we have to find dz. So what is dz? It is basically dou z by dou x into dx plus dou z by dou y into dy. So what is dou z by dou x? So here it is 7 dx, and what is dou z by dou y? Minus 2 dy. So this is the value of dz. Okay, so yeah, I hope this is clear what you mean by differential. Suppose one need to find differential of this one. How will you find it? Dz is equal to dou z by dou x, that is nothing but 3x square y square into dx plus dou z by dou y is nothing but 2x cube y into dy. Now I hope you understand what you mean by differentials. Okay, now coming to the applications, we are taking the convention that, so we will, what do you mean by this dz? So dz is actually taken as the change in z. Okay, and dx denotes the change in x and dy denotes the change in y. So delta is usually means change. Okay, for example, if my x point is, for example, if my x is 1.000 and my new point x plus delta x is actually 1.001, the change in x is nothing but 0.001. So del dx denotes this change in x. So dx is approximately equal to change in x. Similarly, suppose my z is equal to x in y, x into y. Okay, so and similarly we can say what is y. So y denotes, dy denotes actually the change in y. Okay, so with this ideas in mind, let us do some problem here. Okay, so we have to study this formula. This formula helps you to compute. So suppose I have a point like this x0, y0, and suppose my function f is dependent on x comma y. Suppose my function z is dependent on x comma y, and I have an initial point x comma 0, y0. Suppose I am taking a new point called x0 plus delta x comma y0 plus delta y. So I need to find the change in z when x0 y0 changes to x0 plus delta x y0 plus delta y. Now this results give you the change in change in z when the x0 y0 point changes to x0 plus delta x y0 plus delta y. So the formula is nothing but the differential of z at the point x0 y0. So dz is nothing but the differential of z at the point x0 y0. So with that idea, let us do this problem. Okay, so let us find the change in the approximate value of xz is equal. So we are taking the function as z is equal to xy square. That is our setting. Please read the question. Okay, and I have taken my initial point x0 y0 as 0 0.5 1.0, and I am changing this point to a new point called x0 plus delta x y0 plus delta y. The new point, the value of the new point is given by 0.503 1.004. So we need to compute the change in z when x0 y0 changes to x0 plus delta x y0 plus delta y. One way of computing the changes, we can directly substitute the value of x0 y0 into z and you will get a value. Then you can substitute the value of x0 plus delta x plus y0 plus delta y into the formula of z and you can compute the value and you can see the difference. So that is the direct way. Okay, we will compute this change using differentials using the formula dz is equal to this for using the differential formula. So let us try that one. So what is the differential formula? It is dz is equal to fx at x0 y0 into dx plus fy at x0 y0 into dy. Okay, so what is fx? Fx is actually x into y square. So basically it is nothing but y square at the point. You should have supply the point x0 y0. We'll come to that now. So y square dx. So the first step is you write the differential plus fy is nothing but 2xy dy. Now we substitute the points x0 y0 here. x0 is 0.5, y0 is 1.0, and dx is nothing but the change in x. What is the change in x here? So x has been changed to 0.503 from 0.5. So dx is nothing but 0.503 minus 0.5, which is actually 0.003. Similarly, dy would be 1.004 minus 1, which is nothing but 0.004. Okay, so our dz would now be computed as, so it is y square into dx. So y square is y0, so it is actually 1 square into dx is actually here 0.003, 1 square into 0.003 plus 2 into x value is 0.5 into y value is 1 into dy is 0.004, and this way you will get the value of change in z. Okay, so read the question. The question is asking you to find out the approximate the change in xy square to its value 0.503 using differentials, and we have to compare the magnitude of error in this approximation with the distance between the points. So this is the value which you got when you substitute for differentials, and the value of the, so to compute this value, and the value would be here, they have computed it, it is actually 0.007. You can try it. Okay, now how is the error coming into this approximation? So we will look at this in another approach. So basically our function is actually z is equal to, I hope it is, I think it is xy square, right? Yeah, z is equal to xy square. So basically what is the actual change here? My initial point was 0.5, 1.0. My new point was 0.503, then 0.00, 1.004. So the original change is obtained by substituting this value into z, then taking the difference from the substitution of this value into z. That is, first I will substitute this point 0.503 1.04 into z. So that is, I will get it as 0.503 into 1.004 the whole square. Then I will take the difference from again 0.5 into 1 square. So this is the actual change in z. Okay, you can compute that. So the actual change in z is this, but the approximation we got from differentials was this one. So what is the actual change? They have computed it. It is nothing but 0.007032048. So this is the actual change. So what is the error in the approximation? The error in the approximation is nothing but dz minus delta is the magnitude of this will give you the error. What is it? So it is actually something equal to 0.000, okay, 0.32048. So you can see that actually the magnitude of error is very small. Okay, so actually d is a dz is a very good approximation of delta z. Okay, now they have also asked you to compare the magnitude of the error in this approximation with the distance between the points. Compare the magnitude of the error in this approximation with the distance between the points 0.510 and 0.503, 1.04. So it's very simple. How you know the magnitude of the error? Now you find the distance between the 2 points. What is the distance between the 2 points? You know the 2 point formula, it is basically root of 0.503 minus 0.5 square plus 1.004 the whole square, sorry, 1.4004 minus 1 the whole square root of that. So this is the distance. You divide the error with this distance. So that is the comparison. So just divide the error with this distance. So we'll get the answer as, so we can write like this. So you have, just a second. So we have obtained the magnitude here. So you have to the distance. The distance is actually 0.005. So you just find this value 0.006. So this is the comparison of the error in the magnitude of error with the distance. So you just write as 0.0064096. So this question is straight away taken from your textbook. You can once again go through the steps. So it's very simple. So these type of questions are very standard in differentials. So let us try to do one more question here. Okay, so use a total differential. So read the question here. Use a total differential to approximate the changes in values of f from p to q. Compare your estimate with the actual change in f. Okay, so you will the same procedure. So first you will try to approximate the change delta f using df, the differential. So what's the formula? Df is nothing but fx dx plus f by dy. I hope you understand this step. So if you take this problem, fx would be actually 2x plus 2y minus 4 into dx. Again fy would be, just think it is nothing but 2x into dy. Now we need to find fx at that point. So basically when you have to substitute x0 y0 into this formula, so here x0 y0 is, so here they are asking you to approximate change in the values from p to q. So p is the initial point, so this is your x0 y0. Okay, so when you substitute, so x is 1, y is 2 here, you substitute it here. How will you find dx? Dx is basically change in x, which is nothing but 1.01 minus 1, which is 0.01, and dy is change in y, which is 2.04 minus 2, which is again 0.04. So you can substitute it, you will get the approximate value. Now how will you find the original value? The actual value is obtained by substituting this value of q into f of xy. Then you substitute the value of p into f of xy and you find the difference. So that would be the actual difference. So then the error would be nothing but modulus of df minus delta f would give you the error. So this is how you do the problems on differentials. So I hope it is clear. Now we will do one more problem on a different type of problems. Very easy. You have studied it in your lower classes. Okay, so once you have a quantity, suppose z is a function of, maybe z is a function of x, f of x comma y. Okay, so basically dz denotes the change in z and dz by z gives the relative error. So dz gives you basically, if I suppose I need to measure this z using x comma y. Okay, so while measuring, suppose there is some error in x, suppose that error is called delta x, and suppose there is some delta y, is the error in y. For example, suppose the actual value of x was 1.002, so while when we measured it, maybe the value of x was 1, so the error is actually, error factor is actually 0.002. So this is the error in x. Similarly there can be an error in y. So we need to find the error in z. Okay, so error in x is actually approximated by dx, error in y is actually denoted by dy, error in z is denoted by dz. So we have dx by x denotes the relative error. So this denotes the relative error. So dz by z also denotes the error. So they can ask you questions like find the relative error, or in more common way they ask you to find the percentage error. So percentage error is obtained by nothing but dz by z into 100 gives you the percentage error. So they will tell you that, so suppose z is a function of x and f of x comma y, and x has a percentage error of 5%, y has a percentage error of maximum of 5%, find the corresponding percentage error in z. Okay, so The percentage error in x means you have the value dx by x into 100. Also you have the value dy by y into 100. From that you need to find dz by z into 100. So these type of problems can also come up for the exam. Let us try one problem related to that. Okay, so just read this question first of all. The length, width and height of a rectangular box are measured with an aperture of at most 5%. Okay, use a total differential uh, to estimate the maximum percentage error that results if these quantities are used to calculate the diagonal of the box. Okay, so here they tell you that they can get a maximum of 5% error in L and the length, width and height. So we need to find the corresponding percentage error, maximum percentage error that comes when the computation of diagonal of the box. Okay, so basically what's the diagonal of a rectangular box? So if it is a rectangle, it is a two-dimensional, diagonal would be simply root of L square plus B square. Okay, so if it is three-dimensional, it will be simply root of L square plus B square plus H square. So basically diagonal here is nothing but root of L square plus B square plus H square. Okay, so we know the percentage error of LBHS. They have told you to find you the maximum percentage error of D. Okay, so what we will do is that we will give the maximum possible error. So the maximum error in D would come when there is a maximum error in the computation of L, L, B and H. So we will give the maximum possible of errors to L, B, H and H. So suppose what is the maximum percentage of L? So it is dl by L into 100 is given as basically 5 by 100. So basically dl by L is given as just 5%. Okay, 5. Similarly, dB by B into 100 is given as 5. And similarly, dH by H into 100 is given as 5. So using that result, we will try to find the maximum percentage error in D. That is, we will try to find what is dd by D into 100. So let us try to do that. So we know that the value of D is root of L square plus B square plus H square. So first let us compute what is dd. What is dd? It is nothing but, so D is actually root of L square plus B square plus H square. So what is dd? So it is 1 by 2 root L square plus B square plus H square into 2L. Okay, so 2L into dl. Okay, so basically dd is nothing but dou d by dou l into dl, the differential formula, plus dou d by dou b into db, this is our formula, plus dou d by dou h into dh. Okay, so this is the formula, so I am applying it here. Okay, plus, so next one, dou d by dou b, again you will have 2b by 2 root of L square plus B square plus H square into dB, and similarly you will have 2h dh by 2 into root of L square plus B square plus H square. So by simplifying you will get as 2 is cancelled out. I can take 1 by root of L square plus B square plus H square outside. So this is nothing but L dl plus B dB plus H dh. So this is the value of our dd. Okay, so I hope you understand how we found differential. So we need actually dd by d. Okay, so we need the value of dd by d. So this is actually your d only. So what is dd by d here? So it is dd by d would be again 1 by, so d square. Okay, so this is your L square plus root of L. This is already d is there. So I am supplying one more d. So I have 1 by d square into L dl plus b db plus h dh. Okay, so this much we have got. Now we know that dl by L into 100 is equal to 5. So what is the value of dl? dl is nothing but 5L by 100. Similarly, dB would be 5V by 100 and dH would be actually 5H by 100. So we will substitute this into this result. So what will you get? So the result is actually, so this is 1 by d square into L into dl is actually dl is nothing but 5L by 100 plus b into 5b by 100 plus h into 5h by 100. So if you take the common factors 5 by 100 outside, you will get this as 5 by 100 is outside into 1 by d square in brackets L square plus b square plus h square. Now what is L square plus b square h square? It's nothing but d square, because d is root of L square plus d square plus h square. So this will, both of them get cancelled out. So we'll get this as 5 by 100. So dd by d is equal to 5 by 100, or the percentage error is nothing but maximum percentage error can have is actually 5%. Okay, so this is a application of differentials applied to a word problem. So there are many problems of this type. In every problem you need to find this dd by or d, whatever it is, you have to find the differentials. Okay, so you can see one more question. The length and width of a rectangular measured with errors at most 3% and 5%. So here we are using maximum percentage error in the calculated area. So area here is actually L into B. Okay, so I need to find the percentage error in areas I need to find. So you just try what you want to find out. So dA by A into 100, I need to find this quantity, and what is given to me? It is given that dl by L into 100 can be a maximum of 3, and dB by B into 100 can be a maximum of 5. So we will apply the results here. So let us try to do this problem also. So what is dA? First of all, dA is nothing but, first you differentiate it with respect to L. So it is B dl plus L dB. Okay, so first you write dots will be dou A by dou L into dl plus dou A by dou B into dB. So this is it. So B dl into L dB. Okay, so I need dA by A. So I'll divide it by A. A is actually LB. So you will get this as dl by L plus dB by B. Okay, by some cancelling out the factors. Now we know that dl by L into 100 is actually 3. So dl by L is actually 3 by 100. So this is 3 by 100. Okay, and dB by B is into 100 is actually 5. So dB by B is actually 5 by 100. So this is actually 8 by 100. So that means dA by A into 100 is just 8%. So this is how we apply differentials. So I hope it is clear. These are the two type of problems that can come from differentials. One is they can ask you to find the differential, or they can ask you use differential to approximate the change in Z when some point changes to some point, and then you have these word problems in which errors are there. So I hope it is clear to you. Okay, so we will see about we will do some problems in local linear approximation in the next session. Okay, thank you.